what we have done? Okay, given x0, x1, xn and plus one distinct point, correct? We can have a polynomial degree at most n, correct? And this is a unique polynomial, correct? So we can have a polynomial of degree at most n. Correct? It is clear? So if we have 2 points, we can have a polynomial degree 1 less than 1, correct? Equal to 3, 4, etc. So how many points I am giving to it depend on this, correct? So once you fit a polynomial, so there would be some error, correct? There would be some error. So how do you compute this error? The error is, I will write directly, the error is, this is n plus 1 xi divided by factorial n plus 1 x minus x naught x minus x1 x minus x. That is your errors, where this xi. So here your function f is, let's say f is defined from some interval a b to r. Okay, that is given. F is defined from some interval a b to r. This xi belongs to open interval a b. So that's the error is. That's the error. Okay. So if you want to compute error at some points, correct? So put your x here. Suppose you want to compute error at x half. So put x half here, you get the error. Correct? But the problem is with this term, fn plus 1 xi. See, I do not know my xi. I do not know my xi exactly. Correct? I know f, but I do not know my xi. So I cannot compute the error exactly. Correct? I cannot compute the error exactly because I do not know the xi. It's some point lie between a to b. Correct? So you can write. Remark. We cannot compute exact error since we have no we do not know xi. We do not know xi. Correct? Then how it can be used, this error? So this error is used, or this formula is used to find the upper bound of the error. Upper bound of the error means what? Error cannot be exceeded by this quantity. This formula used to find the upper bound of the error. Okay. So let us work out one simple example if you want. So let us work out one example. So you should do this example. You have your x and you have your f. Okay. Let's say -2, -1, 0, 1. And the values are, I will write. My f is -15, -4. So let me just change this 1. So change it because otherwise we will get some different point on 1, 3. Okay, 0 and 20. Correct? So this is your x naught, this is your x1, this is your x2, this is your x3. How many points we have here? 4. That means we can fit a polynomial degree at most, and this, what is n here? N is 4, correct? So if you have n plus 1 points, we can fit a polynomial degree at most, and here we have only 4 points, we can fit a polynomial degree 3, at most 3. Can you fit? Write down. So how do I fit polynomial degree 3? Yeah, this is polynomial degree 3. That is given by I goes from 0 to 3 here. Yeah, or I have 4. Okay, so if this is my x naught, this is my x1, this is my x2, this is my x. It is not necessary that you have to start x0. You can call it x1 also, correct? So, okay. If you say x0 is there, then this goes till 3 because the point is x3. Li x into f x I. Correct? That is the polynomial. That is the. So can you compute? Let us do it. Okay? It is clear? So let us do it. Okay. So let us compute the, and you should help me. What is L1 or L0 of x? That you have to compute first, correct? L0 of x. Why it is? Tell me by formula. X minus x1, x minus x2, x minus x3 divided by, replace this x by x0, that you know, correct? x0 minus x2, x0 minus x3, correct? That is my L0, x is, correct? So you know your x1, x2, x3, correct? Tell me what is. Your x0 is minus 2, x1 is minus 1, x2 is 1 and x3 is 3, correct? Can you compute it? Only you have to plug this value here to get the L. Do it fast and tell me unique answer. Eh? Come on, fast. Then you can compute your, that's all. Lucky, eh? I am lucky. Okay, compute your L1x. So L1 of x will be what? X minus x0, x minus x2, x minus x3 divided by x1 minus x0, x2, x. Tell me fast these numbers, correct? L2 x, x minus x0, x minus x1, x minus x3, and then you have x2 minus x0, x2 minus x1, x2 minus x3. Correct? You have to compute one more. You have to compute one more, L3x. Come on. X minus x1, x minus x2 divided by x3 minus x0, x3 minus x1, x3 minus x2. Okay? Tell all this L0x, L1x. Correct? Tell me. Okay, so my P3x is my P3x is nothing but L0x f of x0, that also you know, correct? L1x fx1 plus L2 x fx2 plus L3x fx3. Correct? Yes? So now you have to compute L0 from here. L1, L2, L3, correct? fx0 is what? Minus 15, correct? Yes? fx1 is minus 4, fx3 is 0, fx is 20, correct? So now finally you get the answer is 4. Is clear, no? You are doing or not? Do it. At least one example you should work out. Come on, fast. See, if you work out one example, that is more than enough. You don't have to work out many examples. And the solution here, go down. Yeah, go down. Keep on. Go down. Yes. Yes. So this is the next slide. Next slide. And next. Okay. Next. So this is your L note x correct, minus 1 by 15, etc. correct. This is my L1x, this is my L2x, this is my L3x correct. Plug it there and you get your page 3. Okay? Is it clear? Is it easy? Yes. Okay. So this is how you can dump. And out in this place. And out? No. Correct? Now, suppose, is this clear? I am is clear? Suppose in between you are doing experiment, correct? And I miss one information. But later I realize that I missed that information and you want to include that information. Correct? You want to include that. Suppose example, here I have later I realized that I missed my 4 and some number, let's say 10, correct? I missed it, suppose, correct? This number. Okay. Is it possible to write a polynomial without doing much calculation? No. I have to repeat the full procedure. I have to compute L note x again, L1x, L2x, L3x, then L4x, and then do the same procedure. Correct? So, problem is, whatever I did so far till here, I cannot make use of it. Correct? Problem, understand? Suppose you miss some information and later when you miss it, you want to include it. Here, if you include it, you have to follow the same procedure again. You cannot utilize what you have done. Correct? Understand? So this is big. Then Newton idea is, yes, it is possible. Whatever information you want to add, you can add without doing much calculation. Here you have to repeat the full process. Correct? Here you have to repeat the full process. It's clear? So now question is, suppose I realize I missed some information and I want to include it. Then how do I get the polynomial without doing much calculation? It's clear? Oh, I use my then how can I do it? Correct? Question is clear? So idea of Newton is, if you miss some information, you can include it without doing much calculation. Means what? Whatever you have done, you can make use of it. Here I could not make use of it, correct? I could not make use of it. So let us understand this Newton method. Newton form of polynomial. This is what the Lagrange polynomial, correct? This is given by Lagrange, so we call this Lagrange polynomial. But final answer has to be same because we prove that there is a unique polynomial, correct? We prove that there is a unique polynomial. It does not matter you have a Newton polynomial, you will see, or Lagrange, whatever, right? Final answer has to be. It depends what is the procedure. What is the procedure is. So Newton form of polynomial. And you will appreciate this very. The idea of this will be, whatever question I did, I must make use of it. That's how. Okay? So how do it? So let us make some formal definition first. I will make some definition. Definition for divided difference. Divided. Okay. I will make it definition for divided difference, then we will see how we can make use of it. Right? So we have defined, like say, 0th order. 0th order divided to. So 0th order means you you have, I just write this, any point you can write here xi, correct? Any point you can write, correct? Or x or what? This is nothing but the value of this itself. This is nothing but the value of this itself. That's all. This is my, what is first order? So this is first order. First order divided. So first order means, suppose you have two numbers x0, x1, correct? How do I define? Yes? This is my first order. This is a notation. This is a notation. Here you, correct? This is simply a notation. This is defined as f of x1, you know the value, f of x0 divided by x1 minus. See, everything is working because we have assumed that these are distinct points, correct? You might get, I told you beginning. Everything based on the assumption that these are distinct points. Similarly, if you want to, any arbitrary, if you have 2 points, correct? Xi minus 1 and xi, correct? This divide written as simple f of xi, okay, minus f of xi minus 1 divided by xi minus xi. Correct? This is my second order divide difference, correct? So you can write, so if I am writing for this, the same thing is true for this, correct? It is clear, no? Yes? Yes. So, okay. So I will write only for x0, x1, correct? But you can write for any 2 points, correct? It is clear? So I will by default, now I will write for only x0, correct? This is x0, x1, correct? So this is not required, this is just for your experience. Now second order. Second order divided difference. So you have here f x0, x1, x2. How do I write? Correct?
So I write there f x1, x0.
Huh?
Both are same f x0, x1 and f x1. Second, first order divided.
Yes, yes, this one. fx1 minus fx1 divided x1 minus x2.
So I write there f x1, x0.
Both are same. That's okay. You can interchange this. Yeah, you go by definition, correct? If you interchange, only you have to interchange this. That I will tell you. One more remark I will make in the last. Okay. Because it links 2 things. Suppose you have a data x0, x1, x10, correct? You can interchange your data the way you want, correct? It should not affect your answer, correct? Yes, I will tell you. But in the last. So, this, how do I write it? F of x1, x2 minus f of x0, x1 divided by x2 minus x0. Okay. So now, how do I attach a meaning to this? By this, correct? Understand? The meaning of f of x2 minus f of x1, correct? And this is also meaningful, correct? So this is all defined. All are defined. Correct? Is clear? So, in general, I can write the kth order divided difference like this. x0, x1, xk. Okay? I can write for k also. Idea is same. Start with the second point x1 till xk minus, yes, it goes till x0, x1 till xk minus 1, correct? Xk, the point before that, and divide by xk minus, correct? So I can write the divided difference, correct? Now what is the use of it? What is the use? That's a question, correct? What is the use of it? So, is clear, no? Is clear? So these are my divided difference. Can you remember it? Okay. Now what is it? So what is Newton form of a polynomial? Let me write. Suppose you have x naught, x1, xn are distinct point. They are n plus 1 distinct point. Then I can have, by using Lagrange, I can have polar degree at most n. Correct? Polar degree at most n. Now I will write the Newton form of a polynomial. So Newton form of polynomial is, so this you write like this from here. This is this. So these are n plus 1 distinct point. My polynomial is Pn of x. I am writing. I'll tell you a naught plus a1 x minus x naught plus a2 x minus x naught x minus x1 etc. plus an x minus x naught x minus x1 till x minus xn minus 1. Okay, mind this is xn minus. So this is a polynomial degree n, at most n, right? Now I have to find these coefficients a naught, a1, a2, an, etc. Correct? And I get the polynomial. Correct? Yes. So that means somehow I must link this ai's with this divided difference. Somehow I must link this ai with divided difference. Okay? How do I do that? Correct? So, okay, my objective is to find this a naught, a1, a2, an, etc. Correct? How do I find? If I do not know anything, how do I find? Tell me. Because this is a interpolating polynomial, correct? This, so since Pn is interpolating polynomial, correct? Polating polynomial. We have Pn of xi is equal to f of xi, correct? Yes? Because this is a interpolating polynomial. I goes from 0, 1 to n. Correct? Yes? How many unknowns we have? We have exactly n plus 1 unknowns, correct? And from here you get n plus 1 equation. You get n plus 1 equation. Solve it and get the answer. So, for example, suppose you see what happened to, I want this on the board. Suppose you take I equal to 0, correct? You take I equal to 0. So this is your Pn of x naught, this has to be f of x naught, correct? Yes? Equal to what? It has factor of x minus 1. All these have factor of x minus 1. This will be 0 and you get your a naught back, correct? Yes? Very good. So that means my a naught is nothing but the 0th order divided difference, correct? My a naught is nothing but the 0th order divided difference. Okay? Now can you compute for x equal to x1 and see what happens, correct? A naught you understood, correct? So we go for x equal to x1. Then do it. Do it please and tell me. I did for I equal to 0, you do it for I equal to 1. I must get from I equal to 1, a1. Correct? A. What is my a1? You tell me. Do it please, everyone. I want my a1. So now, okay, tell me. So for I is equal to 1, what is my a1? Or yes, you get a1, correct? Hold on. Yes, that. Okay, anyway. Don't tell me. Do you think A1 is nothing but f of x0 x1? What is A1 here? You get A1 as f of x1 minus f of x0 divided by x1 by x0, correct? This is precisely your x0 x1 is correct. This is precisely your. That means these coefficients are linked with this, correct? These coefficients are linked. So the idea is we prove that, okay, this is the idea. We prove that this AKs, okay, are given by this divided, are given by the divided. That's the idea, correct? So we will not solve here again system of equations, correct? We will not solve here system of equation again. Directly I can prove that this my AKs are correct. This is the idea. This is the idea. However, question is the computation of this also very difficult, correct? The computation of this also very difficult. This can be avoided if you write a tabular form. If you write a tabular form and you get the answer. Is this clear? So now I will remove everything. Yeah. So what is the Newton form now? Correct? If you know your A0, A1, A2, AN, etc., which you will come to know through divide difference, plug it here and get your answer. Plug it here, get your answer. Correct? So how do I compute? How to compute? So we have AKs are nothing but given by this divided difference. x0, x1, x2 till xk. Mind it, correct? Okay? We have this, correct? That's all. That's the whole idea. Now question is, how do I compute that divided difference? How to compute divided difference? How to compute divided difference? Correct? How do I compute it? Since I don't know, correct? You can always use your definition, correct? But this will take some time. Okay. Idea is, suppose you have here 4 points. You have x0, you have x1, you have x2, you have x3. Correct? I have this point, correct? And corresponding you have your f. F is given to you. So this is my x, correct? This is my x and this is my f, correct? So this you have f of x0. This will be given to you, correct? F of x1 and then f of x2 and then you have f of x. All are distinct point. All are distinct point. Mind it, this need not to be distinct, correct? Your input has to be different, but output may be same. We don't care, correct? Your input has to be different, but output has to be. No need. That's right. How do I do that? Correct? Look at this column is this one will give you the 0th divide differential because by definition is correct by definition. So this is the nothing but the your 0th correct divide differential. Yes. Now let us go with first. How do I do this? From here itself. What is first one? This minus this divided by this minus this, correct? So just make use of this notation for it. So this will give you fx1 minus fx0 divided by x1 minus. So this I am writing, this number will give you like this fx0 x1. Correct? This one will give you from table. And what is this number will give you? F of x1 x2, correct? Yes? And what this number will give you? F of x2 x3. Yes. So this is how you can compute the first order, not table itself, correct? Let us go with second divide. Second divide difference is like this: f of x1 minus f of x2 divided by this, correct? That means you have to take combination of these, correct? You have to take combination of this one. Yes. Correct? So what happened? F of x1, x2 minus this quantity which you already computed, correct? Divide by, you have to be x2 minus x naught. Look at the corresponding points, correct? Look at the corresponding points, correct? Yes? Look at the corresponding points. So here I get here, this will give me f of x naught, x1, x2, correct? It is clear? Look at this, correct? This minus this divided by this minus. Later you will see, since we have a confusion to see this x2, correct? Later we will see, we will avoid that confusion also. Later we will avoid that confusion also. Wait, okay? Since here you have to see the corresponding point, later we will avoid the confusion, that confusion also, correct? Simply you will subtract this minus this. But wait. Now, what this will give me? This will give me by definition f of x1, x2, x3. Correct? This is my second order divided difference is. It is clear? What about third? Third. This minus this divided by x3 minus x0. So this will give me the your final answer is f of x0, x1, x2, x3. Correct? So from this table I am able to compute my all divided difference. This divided difference helps me to compute they are nothing but a coefficient. They are nothing but So how to write the polynomial now? That's all. You are done. So for these 4 points, what is the polynomial now? Yeah. This is third. What is this number? This is your A naught, correct? This number is A naught. This is A1, correct? This is A2. This is A3. And this is what we need, correct? You have 4 points. So what is the polynomial again? Here P3x is given as A naught plus A1 x minus x naught plus A2 x minus x naught x minus x1 plus A3 x minus x naught x minus x1 x minus x2. Okay, see, correct? Now you know your x naught, x1, x2, x3, correct? These are really given to you. You know your f1, etc. So that means you know your a naught, a1, a2, a3, and that's what my answer is. Correct? Can we do the same example what we have done for Lagrange? Correct? Let us do it. Let us do it. Okay? So let us work out the same example which we have worked out for this. Suppose you have the points. Which example we have taken? What your x is? Minus 2, minus 1, 1, 3. Correct? Okay. What your f was? Minus 15. Huh? Minus 4, 0. Now you have to you have to compute your a naught, a1, a2, a3. So this is my polynomial, correct? This is my polynomial, correct? This would be my polynomial. Now I have to compute my a naught, a1, a2, a3 from a table, correct? Let us do it. This, correct? It is clear now. This one is clear. To everyone, this table is clear. Okay. So let us compute. Okay. So this is my polynomial, correct? Now I have to compute only a naught, a1, a2, a3, and we get the answer. So do it. X, you have minus 2, minus 1, 1, 3, correct? You have f. What is f is? Minus 15, minus 4, 0, 20, correct? Yes? So this is give you your zeroth order itself, correct? So I know at least my a naught. I know my at least a naught. A naught is what? This number is always a naught, correct? Without doing anything, I have my a naught. So now compute the first order. first order divided. Yeah. How do I do that? Idea is this minus this divide by this minus this. Correct? Tell me the number fast. So you tell me this table. Correct? Tell me these three numbers fast. Actually I need only these, correct? To get my A1 I need only this. But to compute A2 I need this also, correct? Otherwise I would not. Come on, tell me fast. Complete this table. Everyone. Tell me these first numbers. So if you work out 1 example is more than enough. 100 example no need, correct? And then I will tell you if you add one information, you can make use of the calculation what we have done. Okay? That's what the Newton idea is. First one 11, correct? Everyone understood? This one is 2. This one is this minus this divided by this 10, correct? Okay? It is clear? Yes or no? Yes. Then go for second order. So how do you do that? You have to take combination like this, correct? Tell me. So 2 minus 11, correct? Divide by 1 minus 2. Tell me the answer. So see, if you want, you can just have a look like this, where this number goes, correct? Okay, tell me. What the answer is? Minus 3. It is correct? Or no? Yes, correct. What about the second one? Second one is? 2. Means second one, how do you compute it? This minus this divide by this minus this, correct? It is 2. If you do mistake, you get wrong answer, that's all. Nothing will happen. So you must get the same answer what we have got for Lagrange. Correct? Because polynomial is unique. Polynomial is unique. So next, so I got this is my A1 and this is my A2 also, correct? Yes? This is my A2 is. Now I want A3, tell me this is the third order, correct? What the answer is? So how to do it? This minus this divide by 3 minus this. Correct? Don't do mistakes here. 1. Okay, very good. Correct? If it is correct, I don't know. Whatever you are saying, I am writing on the board, correct? So I got my A0, A1, A2, A3. Then what you are waiting for? Huh? What you are waiting for? Write down the polynomial immediately. Huh? Come on. So my polynomial is, yes, A0 to have minus 15 plus A1 is 11, x minus x0 is minus 2, so that is plus 2 plus A2 is minus 3 if it is correct, correct? X minus or x plus 2 into x minus x1, that is x plus 1, correct? A2 and then A3 is your 1 and x plus 2, x plus 1 and x minus 1. Correct? And you get the answer. Correct? That's what your polynomial is. If you simplify it, you get the same polynomial what we got for later. But what is the benefit? Understand? What are the benefits? It is clear? No? Huh?
Somewhere minus 3. 11 minus 2, 9.
2 minus 11.
2 minus 11 minus 9.
And divide by this number x, this minus this. Huh? This is what you divide different number, no? Should I repeat or clear? Clear? Or so I can write the point. Now let us understand the advantage. One thing is a remark. Suppose you have this x naught x1 xk. You can interchange the role of any two numbers. You can interchange it the way you want. There won't be any effect. You get a same answer. Because by definition, correct? Because by definition. Now what happened in this experiment? I came to know that I missed some value and that's x equal to 2. I missed it, correct? I have missed it. Then how do I make use of the same calculation? Now I will get a polynomial degree 4. Correct? In Lagrange, I have to again full calculation, correct? Now I am very smart. I will not put x equal to 2 here. It doesn't matter where you put. I will put x equal to 2 last. Correct? Whatever information I missed, either you put in the last. It doesn't matter. Wherever you want, you can put it, correct? Now you can make use of this table here as it is, correct? You have to add one more number here, correct? Correct? So I can use the calculation which I have done for 4 points. Understand? I can use the same calculation which I have done for 4 points. Correct? You have fifth one, put the last and keep on. That's what the advantage of Newton. If you miss some data, you can add it and get the polynomial. So only thing that now you have to have this calculation, correct? It's here, and I get that. So no calculation is required. Okay. What is the error? In this case, error will be same as Lagrange because polynomial is same. Understand? Error will be same, no difference because my polynomial is same. Right? Now, the confusion which he had, like we have to look at this corresponding points, correct? I have to divide by this, correct? 1 minus 2, etc. Correct? There is some confusion comes. Correct? Is it possible to divide? Possible to avoid this 1 minus 2 being etc. That okay? That's the question. That is the question. Correct? Because here we get some confusion. Suppose you only divide this minus this minus this minus this, get the answer, correct? It's very easy. The problem comes once you look at the corresponding numbers, correct? Now, so by definition, if you have this, suppose you want to compute second order, you have x0, x1, x2. This is as f of x1, x2 minus f of x0, x1. This is not finished yet, you have to divide by x2 minus x0. Correct? This is the problem. This is the confusion. Correct? You have to look at the corresponding number. Is it possible to avoid that confusion? Answer yes. Yes, we can avoid this confusion. Only we have x. We will see, correct? Okay. So let us go with. So here my assumption was this x0, x1, xn are distinct points. That's all, nothing else. Now I will add one more assumption. They are equally spaced. Okay. And then we'll see the magic. Then we'll see a magic. Okay. Is this clear? The Newton form of polynomial. Anybody can find it? Not difficult, right? In exam, we ask this question only. In exam, what happened? Sometimes we just miss these numbers, correct? These numbers are not given to you, and we ask the fill the blanks. Then you can do it now, correct? So these are possible questions for exam, nothing more than. They will ask missing values. So they may ask, like here, okay, one more question would be you got a polynomial P3S, correct? They may ask find the value at some missing point, tell me which one you want. Half. They may ask find the value of f at half, correct? How to do? Replace this x by half everywhere, correct? You get your value at half. Correct? What? They may ask find the value at x equal to half in exam. So after getting polynomial, put x equal to half and that's your answer. It is clear? That's a possible way of asking question here, not more than that. Correct? Now our problem is how do I avoid this division by x2 minus x? Correct? If we can avoid, we are very happy. From table everything is done. Okay. So now we define this. So now I have assumption is we have this. This x naught, x1, x, correct? These are n plus 1 distinct point, of course. Distinctly we have to put it, correct? Plus equally spaced. What is the meaning of this? What is the meaning of this? Yeah, the distance between x0, x1, x2, x2 all are same. Correct? All are same. In the sense, so that means if you write xi minus 1, okay, this is always h. This is always h. For I goes from 1 to n. Correct? 1 to. The distance between these two numbers are. So now we'll get idea. Now we'll get the idea. Okay? It is clear? Yes? So this is my requirement is now they are equally spaced. Now I'll make a formal definition of the this is required. We have the forward divided difference. We have the forward. So actually, like we have, see why we are doing to compute this A naught, A1, AN. Our objective is what? To compute the coefficient only. Correct? Whatever we do, I want the only A naught, A1. Correct? So here also we will see if we define forward divided difference, how does this help to compute my A naught, A1? That's it. Correct? Okay. So how do I do it? So define. So the first order is suppose you want to define f of x naught. This is simple notice, correct? This is a notice. So if you want first, you can always write here 1. Okay. So first we can define 0 order also, correct? So if you want, we can define the 0. What the answer is? The answer is here your f of x naught as it is. This is my 0th order forward. We'll see why it's called forward, right? If we have forward, then we must have backward also. Correct? No? Yes. And suppose you want defined delta 1 f of x naught. My definition is here I write f of x1 minus the next point, correct? So forward, correct? x1 you are going to x0 you are x1, correct? f of x1 minus f of x. No division, correct? So in general, if you have suppose one of any point xi in general, correct? How do we define it? You go to next point f of xi plus 1 minus f of x. Correct? So I will tell you something. Okay? It is clear? It is clear? Now how do I write my, this is my first order. Then similarly I write second order, third order, fourth order, correct? How do I write nth order? Now I will write, so this is clear. Suppose you want to compute delta n. Okay? This is another one. Of fxi. What is my definition is? My definition is delta n minus 1 f. This is my definition. You will see xi plus 1 minus delta n minus 1. Wait, let me correct it. Yeah, it's correct. F of xi. Okay. Now start from n equal to. This is true for any n greater than equal to 2. Correct? This is true for any n greater than or equal to 2. So by equal to 2 you get here delta 1, correct? This are the, but you know what definition of delta 1, correct? Delta 1 is defined for any I, correct? This is different. So if you take n equal to 1 also, this you get this back. Suppose you put n equal to 1 here, correct? And you want to get it back, correct? How do I get it? N equal to 1. So this is become delta